Okay, let's look at arithmetic sequences. It's our next venture into the sequences and series chapter. And an arithmetic sequence is simply a sequence where the difference between any two terms is always the same. Uh, what you're doing with arithmetic sequences is you are adding the same thing every time to get to the next term, or you're subtracting the same thing. And whatever it is that you are either adding or subtracting is known as your common difference. All right, so let's look at these, see if we can determine which of the following are arithmetic. And if they are, let's find your common difference. And what you're looking for is whether you are adding or subtracting the same thing to get to each next term. If you look at these, number one, we are adding 6 each time. 5 plus 6 is 11, 11 plus 6 is 17, 17 plus 6 is 23. So this is arithmetic. So yes, it is. And your common difference, to get the difference, all you do is you take any two consecutive terms and you subtract them. So my common difference here, I just chose 23 and 17. You subtract those and you get a common difference of 6, which is the same thing you are adding each time. Number two, this one ends up not being arithmetic because we start by adding nothing to get from 1 to 1, but then we add 1. So that's already changed. Even though it does stay consistent for the next terms, we add 1 to get to 2, we add 1 to get to 3. It then starts changing again after that, and this one is not an arithmetic sequence. This is actually your Fibonacci sequence where each term is the sum of the two previous terms. So the way this one is defined is 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8. And to get one term, you actually add the two preceding terms. This is your Fibonacci sequence. Fibonacci, I may have misspelled it. I think that's right. It's your Fibonacci sequence, not an arithmetic sequence. For number three, what we're actually going to do is write out the first few terms of the sequence. If I plug in 1, my first term is 2 times 1 plus 5, which is 7. My second term, if I plug in 2, is 9. 2 times 2 plus 5. My third term, 2 times 3 is 6, plus 5 is 11. My fourth term, I'm going to go to 4 terms just to be doubly sure, but you get 13 when you plug in 4. And you'll notice that you are adding the same thing each time. We're adding 2. And since I am adding the same thing each time, this is arithmetic. And my common difference is 2. I'm going to have to go through the same trick with number 4. My first term is going to be 1 over 1. My second term is 1 over 2. My third term is 1 over 3. And 1/4, and so on. And the way we're going to find our common difference is we will simply subtract. So my difference from 1 to 1/2, I'll do 1/2 minus 1, which is negative 1/2. So I'm actually subtracting 1/2 to get from 1 to 1/2. And then I need to see what am I subtracting or adding to get from 1/2 to 1/3. So we'll subtract those. 1/3 minus 1/2. Get a common denominator. That's 2/6 minus 3/6. And you get negative 1/6. And that is not the same thing that we added or subtracted for the first two terms. Since it did change, this is not arithmetic. This is actually called your harmonic series or sequence, but we don't need to worry about that. You really don't need to worry about knowing the name of the Fibonacci sequence either. I just decided to throw it in there. In addition to this, we can kind of go backwards where I give you the terms and I want you to write the formula for your arithmetic sequence. Now, this is where people start to have a hard time because a lot of people are just not good at identifying the pattern. What you do see, hopefully, is that you are adding 5 each time. So we're adding 5, we're adding 5, and so you notice that the common difference is 5. And that may be a little thought for you. My common difference is 5. And what most people want to do is say, well, if my common difference is 5, then my formula's got to be something plus 5 because we're adding 5 each time. Unfortunately, that's not the way it works. The 5 actually goes in front of the n. It's 5 times n. And then we need to figure out what is it that we add to get to the correct terms. And what I know is that my first term, when I plug in 1 for n, I should get 2. When I plug in 2 for n, my second term is 7. My third term is 12. So I know this much also. And now I've got to figure out if I plug in 1, a sub 1 is going to be 5 times 1 plus some other number. I don't know what that number is, but I do know that when I plug in 1, I should get 2. And I'm doing this really touchy-feely. I'm almost regretting the way I'm going about this now. Whatever. All right, so I've now got 5 plus some number needs to give me 2. So let's see. So 5 plus some number needs to equal 2. And I know that if I plug negative 3 in right here, 5 minus 3 does give me 2. So that leads me to believe that, let's see, therefore, my sequence is given by the formula 5 times n minus 3. And then I'll test that really quick. I'll plug in 2. My second term should be 7. 5 times 2 is 10. Minus 3 is 7. If I plug in 3, I should get 12. 5 times 3 is 15. Minus 3 does give me 12. So there is my sequence. What you're going to find out with arithmetic sequences is that every single arithmetic sequence is going to be written in the form your common difference times n plus some random number. And that's kind of what I did here, where my c, my random number, is this thing right here that I actually kind of had to figure out. It ended up being negative 3 for this problem. So let's actually do one more where, or maybe a couple more where we're writing the sequence. And we're going to start with this general formula, d times n plus some number, looking at, say, number 6 here. First thing I want to do is identify my common difference. My difference is you pick any two terms and you subtract them. So I'll do 10 minus 13. So I know my common difference is negative 3. So I'll kind of put that on hold for a second. And if I know my common difference, then I know that my sequence is given by the formula negative 3 times n plus some unknown number c. And that unknown number c, that's what we're going to solve for off of this formula right here. And then I just pick any number. What I have here is 3 terms. I know that when n is 1, I should get 13. When n is 2, I should get 10. And when n is 3, my third term is 7. Really doesn't matter which one you plug in. I'll just plug in 1 because I like to use smaller numbers. So if I know that a sub 1 is equal to 13, I'll plug in 1 for my n. That should give me 13. And then we solve for c. Negative 3 times 1 plus c equals 13. Add 3 to both sides and you get 16. So now that I know what c is, I take my common difference and I take my constant, and I know that the formula for my sequence is negative 3 times n plus 16. Good? Good? We'll do the same thing for this one. From 5 to 12, I am adding 7, and we're adding 7 each time. So my common difference is 7. We'll put that on hold for a second. And then I'll go with that general structure for the formula. My nth term is my common difference times n plus some unknown number, and we have to solve for c. And I'll do the exact same thing I just did. I'll start by plugging in 1 because I know when n equals 1, I should get 5. So my first term is 7 times 1 plus c needs to give me an answer of 5. 7 plus t equals 5. Subtract 7 and you get negative 2 for your c. And then once you solve for d and your constant, and you roll that into a formula, my nth term is 7n minus 2. And you notice those do look like lines. It's kind of like slope-intercept form, mx plus b, except we have n's instead of x's, where your common difference is the slope of that line. So that's what we actually end up with an arithmetic sequence. A couple of other formulas, and I think I did give y'all warning this chapter would start to get formula heavy. This is where that starts. if I want you to find the nth term of a sequence, and that simply means like if I want the 14th term or something like that, we can use this formula to find the 14th term, where your 14th term is your first term plus it'd be 14 minus 1 times the common difference. And do remember that a sub 1, excuse me, crazy hiccup, a sub 1, that is the first term of the sequence. I could also ask you to find the sum of the first n terms. So here we're doing partial sums. If I want you to add the first 14 terms, then I'll use this formula. And you actually have two options. This is, even though this one's a little bit uglier, this is the one we're going to use most of the time because we'll have the information for this. We'll use this most of the time, where you have your first term, n minus 1 times d, very similar to this one. It has that n minus 1 times d, only this one has the n over 2 in front, and we actually do 2 times the first term. This one, the second one, we have this option also. You can really only use this one if you happen to know a sub n, which a sub n is the last term. So a sub 1 is the first term, a sub n is the last term. If you happen to know what the last term is, then you could use this formula, but usually we don't know the last term, so we'll end up using this first one over here. So we'll use these for a couple of problems. Let's find the 23rd term in this sequence, and the formula for the 23rd term, or the formula for the nth term, is a sub 1 plus n minus 1 times the common difference. So I need to know what the first term is. Here's my formula, put it in thought land. I know that my first term, a sub 1, is 1. I know that n is 23 because we're looking for the 23rd term. And my common difference, we simply take any two consecutive terms, it doesn't matter, and we subtract them. So my common difference is going to be 13 minus 7, which is 6. So once you find your first term, your n, and your common difference, we simply throw all of this into the formula, which is your 23rd term is your first term plus n minus 1, which will be 23 minus 1 times the common difference, which is 6. And then we'll clean that up. 1 plus 22 times 6. And I'll even let y'all use a calculator on this because y'all have had enough arithmetic problems in the past. So we'll just throw this in the calculator and we get 133. So that is the 23rd term. There we go. Not too bad. You just have to use that formula, and you need to know the formula. Let's see, the sum of the first 41 terms. Now the sum, this is one that's a little bit hairier. Notice I do have my first term. I don't have the very last term. I suppose you could carry this out 41 times to the 41st term, but that's a pain in the butt. So I'm going to say the sum of the first 41 terms, and I will use that S sub n formula. The sum of the first n terms is n over 2 times 2 times my first term plus n minus 1 times the common difference. There's the formula we're going to use for this problem, and we simply throw in what we know. I do know that the number of terms is 41. I do know that my first term is 6, and my common difference is going to be negative 2 because we're subtracting 2 to get to each term. And then we simply take all of this information right here and we'll throw it into the formula. The sum of the first 41 terms is 41 over 2 times my first term, which is 6, plus 41 minus 1, n minus 1, times the common difference of negative 2. And we'll throw this in the calculator, and we'll get an answer of negative 1,394. So there is the sum of the first 41 terms, and that seems pretty low, but remember, we are starting to dive into negative numbers. My next number is going to be negative 4, then negative 6, and so a large negative number seems reasonable here. All right, two more quick problems. Find the 15th term of this sequence. Now I am asking you for the 15th term, which is a sub 15, but don't go crazy launching into this formula right here, finding the nth term. And the reason you don't have to launch into this crazy formula is because this formula right here lets you jump straight to whatever term you want. So if I want the 15th term, I will simply plug in 15 for n. So 2/3 times 15 plus 6. 2/3 times 15, 3 cancels the 15 to give you 5. 2 times 5 is 10, plus 6 is 16. So there is my 15th term. So you actually don't have to use this the formula for the 15th term. You simply plug in 15 for n. And then using the same sequence, 2/3 n plus 6. I thought I had another problem. Whoa! There it is. I found it. Don't worry. I found it. Same formula, 2/3 n plus 6. I want to find the sum of the first 6 terms. Now, this is a problem where I could use that formula. The sum of the first n terms is n over 2 times 2 times the first term plus n minus 1 times d. But this is one of those rare cases where we actually have the option of using the formula n over 2 times your first term plus the last term. And the reason I get to do that is because my last term, I could find my first term, a sub 1 is 2/3 times 1 plus 6. I could also find my last term, which in this case would be 6. A sub 6 is 2/3 times 6 plus 6. And we could work that out and actually use the second formula here, because getting the last term just means I have to plug in 6 to the formula. 2/3 times 1 plus 6 is going to be 6 and 2/3, which is 20 over 3. 2/3 times 6, 3 and 6 cancel, leave you 2. 2 times 2 is 4, plus 6 is 10. And then I will simply use my formula. The sum of the first 6 terms is 6 over 2 times my first term, 20/3, plus my last term, 10. And we'll throw that in the calculator. And you get a nice, clean, sexy answer of 50. I must say I was not expecting that, but there you go. All right, so there's some stuff with arithmetic sequences. Be careful with the formulas. You just have to make sure you use them correctly. And there we go.